Hi everyone. The next exercise is about like terms. Like terms are a concept you should have been introduced to last year, but we can go through it quickly now. So two terms are deemed like if they have exactly the same pronumerals and exactly the same powers or index. So I've got a little expression here, or equation here, that we can look at. And I've said that this blue one here is like and this green one here is like, and we're going to look at why they're like and why everything else isn't like. So starting with 1 and 4, this one has an x and this one has an x. It has no other, they have the exact same pronumerals in both terms, therefore we can call them like. 1 and 2 are not like. This has an x, this has a y, that's different. They have different pronumerals. Similarly, 1 and 3 aren't like because 3 has an extra pronumeral, it has a y on it. So even though they both have x's, the y is different. 1 and 5 are also not like. In this case, it's because this one has an index of 1, this one has an index of 2 on the x, making them different. Therefore, they are not like. 6 and 7 are a bit of a strange case. They're just constants. You can imagine they had an x to the power 0 or some other pronumeral on there. But because they are the same, we call them like. And we'll be able to do something with them in a moment that you've been doing for many, many years. So when we find our like terms, the reason we try and identify them is because now we can collect them together. And to do that, we have to be aware of the commutative property of addition. And when we say that two terms are commutative, we're saying that the order is not important. And in this case here, we've got this negative sign here. Now we know order is important for the negative, for subtraction. So what we're going to try and do is reduce it to addition. And we know from our simplifying earlier in the year that if we put a plus and minus together, it simplifies to a minus. Well, in this case, we're going to go backwards. We're going to take a minus and we're going to separate it out into plus and minus again. Now, once we've done that, this term is being added to this term is being added to this term. And now, rather than subtracting, we're adding a minus term. And that'll allow us to change the order around. And we're adding another term here and the two terms at the end here. Now, this commutative property allows us to shuffle the equation around. So we're going to put all the x's together. So you can see I've taken this x here and I've brought it up the front. And I can do that because with adding, I can change the order. And that's allowed me to identify some like terms that I can collect in a second. I've put the y here from here and the xy from here. Oh, and I've dropped off the 2x squared. I better put that back. Now once I get to this step, I've got all the terms next to each other that can be collected. So I start collecting them up. 2x squared can't be simplified. There's no other x squareds in my equation. But these two like terms can be. 2x minus 3x's would be negative x, negative 1x. 2 take 3 is negative 1. So I've collected those together. 3y, there's nothing to collect with it, so I've just rewritten it. 2xy, nothing to collect with that, I've just rewritten it. 10 plus 7 are like, so I can collect them together. 10 plus 7 gives me 17. Once I've got to this step, I've fully simplified it. I can't simplify any further. Once you've had a look at this and believe you understand it, complete exercise 9b. If you have any questions, stick them in the discussion below. Thank you.